Hi, it's Pavel with another C# exercise from the book Visual C# 2012 How to Program. This one's chapter 11, exercise 7, and it's very difficult to pronounce, so let's try quadrilateral inheritance hierarchy. Alright, that sounds complicated enough. So we will going to write an inheritance hierarchy for classes quadrilateral, trapezoid, parallelogram, rectangle, and square. Oh, alright, I'm already tired just reading this. Use quadrilateral as the base class of the hierarchy and make the hierarchy as deep, as many levels as possible. Specify the instance variables, properties, and methods for each class. Now, the private instance variables of quadrilateral should be the XY coordinate pairs for the 4 endpoints of the quadrilateral. Now, this is what probably will throw off a few people, but I'll explain what they actually mean. Write an app that instantiates objects of your classes and outputs each object area except quadrilateral. Obviously, this one is the base class, so we don't need to, instantiate that one. Now, I have the a little I don't know what you call it, chart or something. This is what they mean by the endpoints. If you read the XY coordinate pairs. So for example, if you do a square of coordinates 5 and 5, 5x, 5y, here's 1 point. The other point would be, let's say, 20 on x and 5 on y, so it would be here. So this is actually the length of the side. If you look at it, it's 20 minus 5, so the length would be 15. That's how we get the length, because in order to calculate the area, we need the length of the side for the square and for any of these quadrilateral objects. So this is what they mean by endpoints. We will declare x and y for 1 point, second point, then that will be a third point and a fourth point, and we will be able to calculate the length of the sides needed to calculate the area of each of the objects. Alright, so let's have a look at it. The first thing, I'm going to create a class and I'm going to call it something like quadrilateral. If I misspelled it, never mind. It's good enough. Quadrilateral. Now we need the coordinates x and y. So the way I'm going to do it, since this is like a pair, x and y, I'm going to declare a structure. So it's gonna be public struct, and I call it coordinates, or coord, like that. And in it, it's like a mini class. You can it will be instantiated the same way as a class. It will have the same kind of characteristics, but rather than creating another class, this will be the part of the base class. So public integer x and public integer y. These are the coordinates of the structure, and in the method, or inside the structure, we will create a method, or actually it's rather a constructor, not really a method. So public coordinate integer at 0.1, integer 0.2, and we will assign our x equals 0.1 and y equals 0.2. So this is our coordinate system, simple structure that accepts 2 points, and it will be together it will actually create 1 point, x and y point. So now we can do actually, you know what, let me do declare the variable coordinate and it's gonna be C1 because we have 4 points, so this is coordinate 1, 2, 3, and 4. And now we can do the constructor for the class quadrilateral. So it's gonna be public quadrilateral, and it expects actually 8 numbers. It expects point x and y, which is gonna be 1 point, so x1, y1, x2, y2. Again, if you look at it, it's going to be x and y. That's 1, but it's 2 numbers, 5 and 5. And then x and y, again, it's gonna be another 2 points, another 2 numbers, which will give you 1 point. So we will expect integer x1, integer y1, that's 1 point, integer x2, integer y2, that's 2nd point, and we will do the same for 3rd and 4th point. So integer x3, y3, integer x4, and integer y4. And this is what the class actually expects. Now, before I move any further, this is actually supposed to be an abstract class, so let me make it public abstract, because we are not going to be instantiated this class into an object. This is going to be just used for the trapezoid and the square and a rectangle, so to inherit from. So over here we can we already have the coordinates in place, so we can now create an object or a structure. So it's gonna be new coordinates, just like instantiating an object. So it's gonna be x1 and y1. So this is the first point. This is gonna pass over here, and this is going to give us x1 and y1. This is the 1 point. And now let's do the second one. Coordinates, it's gonna be x2 and y2. C3 equals new coordinates x3, y3, and finally C4 equals new coordinates x4 and y4. Okay, so that's our constructor. Now, since we have a points, that's not what we can use to calculate, you know, the area. In fact, I found on Google, this is how you calculate, you know, the parallelogram, area, rectangle, square. Obviously it's a simple trapezoids, but you need the sides or the length of each of the sides, or some of the sides, in order to calculate the area. So we need to figure out how to calculate the length. So public integer, and I'll call this length a, because there's gonna be 4 sides. Each of these will have 4 sides: square, rectangle, trapezoid, and parallelogram. They all have 4 sides, 4 points. So this is gonna be a, and this is a public method, and it will return the length. So again, let's say I have 5 and 5 and 20 on x and 5 on y. Here the length is 20 minus 5, which is 15. So in order to return it, the length, we will return, and we will return, if you look at it again, it's going to be the x2 point minus x1 point. So we will do x2 point is coordinate c2, so it's gonna be c2 of x, the x point, minus, and x1 point is coordinates 1, so it's gonna be c1 x, and that will give us the length that we are looking for. It will give us this side. Now we have to realize that this could go into negatives as well over here. But let's imagine this is negative 20 and this is negative 5. If you add, if you try negative 20 plus minus -5, you'll get 25. You don't get 15. Therefore, in order to avoid that, in case the user enters negative numbers, we are going to do a math that the ABS, the absolute numbers, in other words, it will give us only positive numbers. So even if it's a negative number, -20 and -5, it will give us 20 minus 5, which is still 15, regardless whether it is positive or negative. That's what we need. In case, again, the user enters negative numbers. So now we can calculate the length B. For example, if it's a square, it would be this one. Let's say it would be 5 and 15, another point here, and 20, 15 would be here. So, like for the square, it doesn't matter, because if you look at the square area, we just need one side, and it's a squared. I mean a to the power of 2. So we technically don't need it. But for the others, like for example for the what is it, trapezoid, you do need A and B, and you need the height as well. So we can as well do that. We can do all the lengths of all the sides. We will use them down the road. So I'll just copy paste them, except this one will be length B, this one will be length C, and this one will be the last one, length D. Again, we may not even use them all, but if you decide, if like some more complicated 4-side object to calculate, this way you'll be able to add it easily. Now length B now equals, so this was x2 minus x1, but this now is going to be x4. This is the last point minus the third point. So this is point 1, 2, 3, 4. So the fourth x minus the third x. So over here it's gonna fourth x is c4, so it's gonna be c4x minus c3x. Length C, if you look at it, it would be this one. So it's the point y 3, because again this is point 1, 2, 3, and 4. So this is third. So the third y minus the first y. So this one will be the c3, but not x, but y, minus c1 y. And the last point, it's going to be, once again, it's going to be y, and it's going to be the fourth y minus the second y. All right, so that's c4y, where my mouse just disappeared. So c4y minus c3 y, actually c2 y, because it would be this side, so 4 and second point. Okay, so these are our lengths, c2 minus c1. Let me just look at it quickly if I didn't mess something up. 3, 2 minus c1 and c4 minus c2y. Okay, now in one of the cases, for example here the trapezoid, you also need the height. Now the height is easy to calculate. It's basically the y point on this side minus any y point on this side. Again, this is a parallel, so it would be a y. We don't need to calculate, like the angle or anything like that. It's simply the difference between these two sides. So when I look at my painting here, let's say I have a trapezoid like this, and the height would be, if this is the coordinates for the y, which is on 5 and 15, it's going to be simply 15 minus 5. The height would be 10. All right, so let's do that. Let's calculate the height. So public integer height, and it will return, and again it's gonna be the math dot absolute numbers, and what it's going to return is, if you look at it, it's gonna be the difference between the 0.3 and 0.1. So it's gonna be C3y minus C1y. This is the height of the object. This is the third point. This is the first point. Even though it's under the angle, we are just we're not considering the full coordinates x, y, only just the y points. And the y point is 5 here. The y point is 5 here. Here it's all the way, just like over here it's 15, 15, 15, because we are going only on one axis, in this case on y-axis. All right, so that's our height. And let's do a toString method. toString, and we will return, I would say, something like string.format, and each of the objects will need an area to calculate it. So we can do in this base class, we can do total area is, and just do a placeholder here. Oops. And this is, it's gonna be the area. So the area is area, and each of the other objects will inherit this. So we won't have to print or type this again in any of the other classes. But the area will be calculated by a public with the get area method. Now this is an abstract class, and I'm not going to be declaring or instantiating this class. So this method will be abstract as well. But every other object or every other class that inherits from this one will have to put this in place. So it's gonna be abstract double. I'll call it get area. So over here in the toString, the total area is, and the placeholder will hold the result of the get area method. All right, so yeah, that's our base class. So what's the next? So they want us to inherit, the quadrilateral. That's the base class, and then trapezoid. So let's do that one next. So I'm going to create a class, and I'll just call it trapezoid, just like that. And this one will inherit from the quadrilateral. So in the constructor for the trapezoid, we need 4 points. So I'm just going to come over here and copy this, because this is the same thing. If you look at the formula for the trapezoid, I need 4 points because I need this side, I need this side. I technically don't need neither of these sides, but I need to calculate the height. So I need the points for this particular side. In other words, I need 4 points, or at least 3 points. This one, and this one, in order to get the side A and B. No, actually I need this one too in order to get the A side. So I need all 4 points in order to calculate these the side down here, the side this, and to calculate the height as well. So the trapezoid, I will simply do this, and since this is inheriting from quadrilateral, now we have to go to our base class and pass all those numbers there, because the quadrilateral expects x1, y1 all the way to x4 and y4. So it's gonna be x1, y1, x2, y2, x3, y3, and x4 and y4. So this is our constructor. oops, not like that. And inside we can calculate the sides that we need and the height that we need. Now in order to do that, I will declare a read-only property, public read-only, and it's going to be, I'll call it side A. That's going to be one side. I need read-only integer side B, and I need it doesn't have to be read-only, but I'll make it read-only, just why not, integer, and this is going to be the trapezoid height, so T height. Now since these are read-only, I can only set the values in them inside the constructor, so I have to go to the constructor and do side A, and side A will equal to our length A. That's this. That's one length A. That's how we calculate it. So I will simply call the method length A to get the side A. Similarly, side B will equal to the length B. Not A, but B. I think I misspelled this thing. Length A. Okay. And the T height, the trapezoid height, will equal, remember, we are also calculating the height here, so we will simply call that method. So height. And that will give us all the values that we need to calculate the area. So now I can come down here and create a public and override. Remember, the abstract class has an abstract method called getArea, so I have to use override string. What am I doing? Not string. It's a double. And getArea. And in it, I'm not gonna throw any exceptions there. I'm going to calculate the area. Now the calculate the area is A plus B divided by 2, and all of it multiplied by h, which is the height. So I will return, and let me see how that goes. It's side A plus side B. This is divided by 2, and all of it is multiplied by the height, so which is the T height. Okay, so that should give us the area, and finally I can go public override string to string, and I can actually keep it this way because since I'm overriding the area, it will actually come over here and it will say total area is, and it will return the value that I just calculated from the getArea of my trapezoid class. So that's what I mean when I said that once we type this, all the other classes don't have to type anything. We will simply call this toString method in our base, and it will output everything as we expect and need. Okay, so that's the trapezoid. Next, the parallelogram. All right. So let's create a class called Parallelogram. Okay, like that. And we'll do something similar that we did before, except this time we're not going to inherit from the quadrilateral. We are going to inherit from the trapezoid, because this is the trapezoid and this is the parallelogram, which is basically, again, very similar, and we need the height and we need one side in order to calculate the area. So I will do, first I'm going to do public read only. Oh, I'm out of class, that's why, never mind. So it's gonna be public read only integer, I'll call it side. We only need one side to calculate the area, but we need the height as well. So public read only integer, and I'll call this parallelogram, so p height. So these are my properties. So inside of my constructor for the parallelogram, I need one side, so I need 2 points, but since I need also height, I actually need a third point. Again, if you look at it, I need one of these sides, but I also need at least the beginning of this side to see the y, the y point of this side in order to calculate the h, which is the height. So I will need, let me just, I will need these x1 through x1, y1, x2, y2, and x3 and y3. So these I need, but of course, since I'm inheriting from trapezoid, trapezoid expects also x4 and x4 and y4. So I'm going to pass all these, well, not without the integers, x1, y1, x2, y2 into our base class. And for the other 2 points that I don't need in this case for my parallelogram, I'll simply put zeros there. But I do need to put something there again because it expects actually 8 numbers. So I cannot just put 6 of them there. And within the constructor, I'm going to call the side equals again the length a, just like before. Length a, and the height. Oh, it's actually p height. Sorry, p height equals height. So that's that will give us the side that we need and the height that we need to calculate the area. So over here, public override double get area, and in order to calculate the area, it's b, which is the side, times h. So I will return the side times the height, which is the p height. And finally, I'll do the toString methods, public, again override string to string, and here we go. It will again just go to a, it come over here. This inherits from quadrilateral, so it comes over here and outputs total area is, and whatever the calculation of the total area is. So that's our parallelogram. Next, I believe, is a rectangle. All right, so let's create a rectangle class. And it's gonna be very similar. I will create some properties, public read only properties. I'll call it side A, and public read only property side, and I'll release B. See, if we go over here, we're not interested in B side. The B side in this case is this. This is A, and this is B. We don't, for the rectangle, we don't care. We need this side. All right. So this is side A. This is side B, and this is side C. So I'm gonna call it side C, just so because we are not going to call length B, we're going to call length C, just so this kind of matches. You could call it side B, it wouldn't matter, as long as you call the proper method in the quadrilateral, which is the side C, which is the vertical side, not the horizontal. Okay, so we have that, but I forgot one thing. I forgot that it has to inherit from, and in this case, parallelogram. We don't need to inherit from quadrilateral. We can do it from here because, in fact, it's gonna be easier because we need 3 points as well, just like we need over in a parallelogram. So I'm gonna actually take the whole thing and I'm gonna create a public rectangle and I'll just pass it in there. And in our base I will simply pass the x1, y1, x2, y2, x3 and y3. I don't have to pass anything else because again we are inheriting from parallelogram, and that expects 6 numbers to create 3 points. Just like the rectangle, we need 6 numbers to create 3 points. So, and inside the constructor I'm going to do side A equals the length A, and side C, like I said before, it doesn't equal the length B, it actually equal the length C. If you look at the rectangle, we need to calculate, we need to have this side, which is, in our case it's side A, and we need this side, which is in our case side C, because this is what I have set up as side B. I have this as A, B, C, and D. But these are methods, so I need parentheses like that. And now we can calculate the area, so public override double and get area, and the rectangle formula again is side A times multiplied by, in our case, side C. So I will return side A multiplied by side C. And let's do the obligatory toString method, so string to string, and we can keep it as is, just like we did before. And finally, it's the square, so create a class, add class square, and square will inherit from rectangle. And in order to calculate square, as you remember, we only need one side. We actually, doesn't matter which side because they're all the same length. So I'm going to create public read only integer side, and in the constructor of the square, public square, I only need 2 points, so I need x1, y1 to create 1 point, and x2, y2 that creates the length, the second point, and I can create or calculate the length, and that's all I really need for square. So it's gonna be integer x1, integer y1, integer x2, integer y2. But since we are inheriting from rectangle, we need to call the base and pass some numbers. You can see that it expects also x3 and y3, so we will pass our x1, y1, x2 and y2, and for the other two numbers, x3 and y3, we don't need. I'll just pass 0. So that's that. And inside the constructor, let's call the side equals, and all we need the length A. Length A. I probably misspelled it again. Length A. There you go. That's all we need to calculate the area, so we can just do that. Public override double get area, and we will return. Again, if you look at it, it's A to the power of 2. So we will do our math.power, and it's the side that we do the power of 2. So side and 2. And finally, let's do the public override toString method, just like that, and it's already finished. So these are our classes. Now let's go to our program and instantiate them and test them. So I'll come over here and I'll create a square s equals new square, and you can see it's asking for 4 numbers, x1 and y1, and x2 and y2. So let's just give it something. Let's give it 5, 20, 20, and 20. So if you look at it on the over here, let me just delete these things. So if I do 5 and 20, that's the coordinates over here. I'm sorry, that's the coordinates over here, 5 and 20. And 20 is coordinates over here. And that's all I need. I need this side, which is obviously 20 minus 5, it's 15, and I'll be able to calculate 15 to the power of 2. So that's gonna be the result for the square. Okay, so that's our square. Let's do the rectangle. Rectangle, I call it R equals new rectangle. And I'll pass again, let's say 5, 20, 20, 25, and 30. So let's look at that. What do we get here? I don't know if you can see it. Oh yes, you can, I'm sure. Anyway, so it's 5 and 20, which is here. The other point is 20, 20, just like it was for the square, which is here. And the next point is at 5, 30, which is here. So you can see the length of this side is going to be 15, 20 minus 5. The length of this side will be 10, 30 minus 20. So when we multiply 15 by 10, obviously we get 150. That should be the area of the rectangle. Okay, so that's the rectangle. Let's do the parallelogram. P equals new parallelogram, and this time it expects we can give it similar numbers, I guess. 5, 20, and 20, and let's another 20, and 10, and 30. So parallelogram, if you look what it is, it's this is how it looks. The side is under angle. So if you come over here and do our 5 and 20, which is here, and then 20, 20, which is here, and then do our 10 and 30, with 10 right here and 30 is here, then we get the two sides. That's kind of that we need. I mean, obviously there's 4 sides, but in order to calculate that, we only need these 2, because now, in fact, I need only one side, but I need the height. But since I have this side and I have this point over here, I can calculate this height, which obviously is 30 minus 20, which is 10. So that's the parallelogram. And finally, the trapezoid. T equals new trapezoid. And this time we need to enter all the numbers. So let's say 5, 20, 20, 20, 10, 30, 15, and 30 again. So let's do this one quickly. So the familiar 5 and 20, 20, 20. So that's one side right here. The next one is 10 and 30, which is here. So that's gonna be this side. And finally it's 15, 30, which is gonna be here. So now I will be able to do this side as well as this side. And in order to calculate the trapezoid, I need the height, which is easy now because I have this point, so I can clearly see that 30 minus 20, the height would be 10. So I hope it makes sense how the coordinates work and how you calculate the length of each side and the height of that you need in order to calculate the area. So these are our objects, and right now we can simply do cancel that right line, and we can do square, and declare square. Actually it's just S for my, so that this will output the area, and it will output the area because this thing, you can see the toString outputs the total area. So this will output the area of the square. I'll do it for the rectangle, for the parallelogram, and for the trapezoid. So I rename this to rectangle, parallel. Oh Jesus! Who comes up with these names? Trapezoid. All right, and finally console dot read key, just so we can pause the screen. All right, now the moment of truth. Let's run it. And here are our results. Square total area is 225. In fact, let me test that. So 225 for the square. Now, if you look at the square, like we see before, the points were 5 and 20 and 20, 20. So the length should be 15. So if I enter 15 here, we get 225. So the square equals to 25. That works okay. So now let's do the rectangle. The rectangle numbers we entered again was 5, 20, 20, 20. So this would be 15. And we also entered 5 and 30. So this should be 10. So 15 and 10. If we come to our rectangle and enter 15 and 10, obviously we get 150. And we did 150 over here. Now parallelogram, we need the side and the height. So what did we enter? Let me just minimize this, keep moving it around. So for the parallelogram, we entered again 520, that's here, 2020, which is here, so again we get 15, and we entered 5 and 30. So this is parallel, which means that this is the height is 30 minus 20, which is 10. So once again, if I come to our parallelogram and enter 15 and 10, I get 150, just like it came out over here. Total area is 150. And finally the trapezoid, and let me draw that. I mean, I did it already before, but let me just validate the numbers or the results. So if we get 520, once again 20, 20, so this is 15. The next is 10 and 30, which is here. I don't even need to know anything else. Actually I do, sorry, I need the other side, which is 15 and 30, which would be here. So this is 5, 15 minus 10. So this is 5, this is 15, and the height is 10, 30 minus 20. So if I go to my trapezoid, so it's 15, 5, and height was 10. The area is 100, and we can see the trapezoid area is 100 over here as well. Okay, so this is the exercise. Again, we created a base class, Quadrilateral, with the coordinate system as a structure. This expects 8 numbers from which we create 4 points, x and y each. We calculate the length of each side of the each of these objects again have 4 sides, so we calculate each of the sides, or the length of each side. In some of the cases, like the trapezoid, we need the height, so we calculate the height as well. And we have the toString method that we simply says the whole area is, and calls the getArea method, which in this case is abstract, but is overridden in all the other classes. and I use read-only properties that I instantiate in the constructors to get my get the size and the height that I need in order to calculate the get area. Like in square, for example, I need just one side, but in trapezoid I need two sides, and I also need the height of the trapezoid in order to calculate the area. So yeah, that's that. It was just a little longer, but I hope it was helpful. If you liked it, please like the video, subscribe as well, leave a comment, and I'll see you next time. Take care.